This video is going to cover how do you see transformations when given equations versus graphs. Now, to make things easier, I like to do everything the same way if at all possible. Well, I already know how to do transformations by looking at graphs, but when I look at equations, it's a little bit different. Unless I can do a couple of things, right? It is possible to change an equation to a graph just by going to Desmos and inputting it. So that's what I would recommend doing. Again, type everything as you see it. I have f of x is equal to x plus 1 squared. Then I have f apostrophe. What this apostrophe means really quick. This apostrophe just means prime, okay, or the image. So if it's got the little tick mark, it's the image, or you may hear it referred to as prime. So f prime of x is equal to -3 parentheses x plus 1 squared. Again, I'm going to type the equation exactly how I see it. Plus 4. And I get some picture. Okay. Now, nothing has changed. The first thing I want to do is see if I can determine if there's a reflection that's happened or not. Now, the way I do that, again, is I have to be able to find the vertex or get the overall general shape. Well, the red one, or my pre-image, I can tell looks like a U. However, my image, I can't see it. So I'm going to zoom out. The way you zoom out is hit this minus button up here at the top right of your screen on Desmos. And just zoom out until you can see your vertex. Now, if you look at that right there, when I have the prime symbol in, it messes up my graph. So what that means is here's an exception to the rule. So I'm going to actually tell us how do we do it. So a note, cannot put prime in Desmos. Okay, so because you can't put prime in Desmos, you're going to have to make a note either by color or by orientation of which one is your image versus which one is your pre-image. Okay, so that's what I'm actually getting ready to do. The way I suggest doing this is when you type your first function, f of x is equal to x plus 1 squared. I know that this is my pre-image because it does not have the tick mark. The tick mark means prime, which also means image. So I'm going to go from red, and I'm going to write down information about it. This graph is red. The image just so happens to be blue. And the blue image looks like an N, so U and N changes shapes. Therefore, there has been a reflection. Once I get this done, again, it's very important that I can find the vertex. Again, a quick way to find the vertex is when you put your cursor in a function, Desmos will go ahead and plot the key features for you. Now, because I'm not, or I don't like looking at a whole bunch of stuff at one time if I don't have to, I'm going to tap on whichever one I don't want to look at. So I want to look at the blue one first, which is my image, and I want to find its vertex. Again, if my cursor is on the screen or in that function line, it'll plot every key feature for me. Now again, that's why the vertex was so important. So you're not the vertex, you're not the vertex, you're not the vertex, you are the vertex. So I'm going to come back over here and I'm going to make a note of it. So vertex is at -1, 4. So once I find the vertex of that, I'm going to hide it and I'm going to pull up the red. Now the vertex of this one is at, you're not the vertex, you are, is at -1, 0. So what movements get me from the point -1, 0 to the point -1, 4? Now I'm going to hide both of these because I'm just concerned with point movement. So I actually zoom in and I think about it. Well, to get from purple, or I'm going to actually change this, point to red since it belongs to my pre-image. I'm going to change the black one to blue since it belongs to my image. So how would I go from red to blue? I wouldn't go left or right. So there's no horizontal shift in A. But vertical shift, I'm going to go up. Now I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And a bunch of us are going to say 8 here. We may say 2. Be careful, look at your scale, right? So in my case, based off of my window right now, my scale is 0.5, right? 0.5, 1, 1.5, 2. Pay attention to your numbers on the axes, okay, guys? That's like a tip I can give you. So I've gone up 4. Now a vertical, it's either going to be a stretch or a compression. To figure it out, I have to figure, do I go from wide to skinny or skinny to wide? So I'm going to zoom in a little bit. And over the same amount of time, the red, you have to make a judgment call. This is where being a visual learner is actually really cool. You have to make a decision which one is wider than the other. Okay, so I'm going to say the red is wide. And I'm going to say the blue is skinny. And I'm going from red to blue. So red, wide, blue to skinny. So wide to skinny. So because I went wide to skinny, I have a stretch. You guys, again, remember you can't put your prime in Desmos, just type your equations and make notes all over the place, okay? The most important being, know your pre-image versus your image. After you do that, I think color is a really big deal. Once you get color, I would then write the vertex of both, right? Because that's going to get us through the horizontal and vertical shifts. Once you get your horizontal vertical shifts, make a decision on which one's skinny, which one's wide, and finish up by vertical stretches and or compressions.